Hello and welcome to another LeetCode problem. Today we're going to be doing the hardest problem from today's biweekly contest. It's not super hard, but it's definitely not like I'd say it's more towards the hard end of the medium problems. There's definitely a decent amount of stuff. Not super obvious. Okay, so you're given an integer n denoting the total number of servers and a array logs where logs I equals server ID time. And so that denotes the server with server ID received at a request at time t. You're also given an integer x and a zero index integer array queries. And then we have to return a zero index integer array r of length queries length, where ri represents the number of servers that did not receive any requests during the time interval queries I minus x queries I. So let's actually go over and explain what that means for this example one. So if we have n equals 3, and then our logs, say L, is 1, 3, 2, 6, okay, and 1, 5. And x is 5, and the query is 10 and 11. So pretty much what this means is they're saying what servers did not receive requests in these time intervals. And by time intervals, I mean you take each time in the query, so you have this 10, you subtract x, so 10 minus 5, and then the time interval you want is the query minus x to the query. So anywhere from 5 to 10 would be the first time interval, and for our output here. So how many queries did not receive a request anywhere from 5 to 10? Well, let's take a look at our logs. So server 1 received a request at 5, and then there was also, let's see here. Yeah, so they're saying server 1 and 2 got a request, right? So server 2 also got a request at 6. The server 1 actually got, this request was before 5, that's okay. So server 1 got a request at 5 and server 2 got a request at 6, which are both in the interval 510. So the only one that didn't get a request is server 3. So here there is one server that didn't get a request. Now for time 11, we do the same thing, minus 5. And so our time interval is 11, 6, and this is inclusive. So I guess it should be like this, right? 6, 11, and this is inclusive. And so how many servers didn't get anything there? Well, only server 2 got something at time 6, and then server 1 and server 3 did not. So that would be 2 servers. So hopefully that makes sense how that one happened. And now let's actually look at the second example. Let's try to build our intuition. So similarly enough, we are going to have our logs. So we have 2, 4, 2, 1, 1, 2, and 3, 1 finally. Okay, so now our x is 2, and our queries are 3 and 4. Okay, well, let's think about that. So for 3, what's our time interval? So our time interval is actually, remember, q minus x to q, so that's going to be 3 minus 2, 2, 3, which is, 1 to 3. And so what got something at interval 1 to 3? Well, server 2 got something, server 1 got something, and server 3 got something. So how many servers do we have? We actually have 3 total, so everything got something at that interval, so that's going to be 0. Now for our second interval, it's going to be 4 minus 2, 3, and let's see which intervals actually got something there, so let's delete this. So for the second interval, we have 2 to 3. So we have something here, and we have something here. So server 1 and 2 did get a request, but server 3 did not. So there's one server that did not get a request. So that's kind of what it is. Now let's actually think of a better way to do this. And for one thing, for what you should immediately be looking for when there is things with time to not do repeated work is you're always going to generally want to sort something. Because with time, the way it's going to work is it's easier if your inputs are sorted, because time is always increasing. And so if you actually have an increasing time and an increasing queries, then there might be some way to make this easier. So how do we actually get sorted times? So what we can actually do is we can sort the logs. So let's see what that's going to look like. And we're going to sort the logs obviously based on time. We don't want to sort it based on servers because that wouldn't do anything. So let's say for our example one, we sort the logs. in order of increasing time. So that's going to be what? So it's going to be 1, 3. Now we're going to have 1, 5, 2, 6. And then what we can actually do also is we can also sort our queries, and that would make it easier to like to change what we're asking from one query to the next, and I'll show you how. And so for our queries, let's actually sort them. They happen to be sorted already, but I don't think they're always sorted. So let's say they're 10, 11. And the nice thing is if you're wondering like, well, I need to return my output in order of queries. So if you want to sort something, but you need an output in this order, it's pretty straightforward. All you do is you just create a new subarray for each one of these with the number that it had before and then the index in the original array. So you would create a subarray like this, right? So you'd have like 10, 0, 11, 1, and so on. And then you can sort it based on the actual query, not by the index. And then once you do some query, like let's say they're out of order and this will be like index, let's say it's like index 8 or something, whatever. You can just say, okay, whenever I process this query, I know exactly where this needs to go into the output. It needs to go at index 8. And so that gives you more options to sort things. And, you know, like if you do have to have something in some way, you can still do it. And I think this was really common in a lot of the hard problems I've done earlier, where you need to sort a lot of stuff, but you need to make sure that your outputs, like you need to know the order of your outputs. Okay, so let's actually use this array here, but yeah, just remember the indices aren't going to matter too much until we are actually putting our numbers into the result. So for every single query, all we have to do, if you think about it, is we have to know how many items are, so let's actually make this bigger. We have to know how many servers weren't called. So what we can actually do is we can have a dictionary. Let's just call this S. We can have a dictionary, and then we can just say for every single server, let's just say the number of times it was called was 0, because a server can get called multiple times in one interval. So what you want to have is for every single server, 0 to, or not 0, for every single server 1 to n. So let's just say in this case we have 3 servers and x equals 5, right? So we just have like 1 is 0, 2 is 0, and that's going to be our initial states. And then if you think about it, then we can just have some variable that keeps track of like servers that weren't called. Let's call that maybe C. We're going to initialize that to, I think we're going to want to initialize that to all of them, right? So we're going to initialize it to n, so we'll just say that's 3. And then how would we change this? Well, it's actually pretty straightforward. Anytime a server's value changes from a 0 to a 1, that means the server is called. And anytime that server's value changes from 1 to a 0, that means that server wasn't called. And anything else, we don't really care. Like if a server gets called once, twice, 3 times, whatever, we don't have to change it. Okay, so now let's actually go through this for the query, and let's show you how this will work. And we're actually going to use a sliding window here. So we're going to initialize our left and our right to be both 0. So we're going to have the left and the right point to the same thing. Okay, and so I'm actually gonna write those variables over here. So I think this is like log. So let's have a left and a right. And what we're actually gonna do is for every query, we're gonna maximize our right. We're gonna make the right go as far as we can, and then we're gonna move the left to make sure our sliding window is correct. And we can actually, so the left and the right are independent here, but yeah, so the left and the right are independent, so we can actually have like 2 loops separately. Usually what I do is I try to increase the right, but then make sure the left is always, you know, like changed in that same iteration. But we can actually go fix the right, then we can fix the left. And then we don't actually need to calculate the size of the window. What we have to actually calculate is this right here, the number of nodes that weren't called. So let's actually see how we would do this for this example. So our first range, so we're going to go through this first query, right? So this query is 10. And so our first range is 5 to 10. So what we're actually going to do is we're going to say as long as the value in here, so remember the left is the server and the right is the time, as long as the value here for our right, it's going to be our right bound, is 10 or less, we're going to keep moving our right. So like our right would start here, and then we'd say, okay, is this value 10 or less? It's a 3, yeah, so we can move it. So let's move it. So we're going to be over here. Now, can we move it again? Yes, we can. Oh, by the way, so every time we like the value is valid, we need to update some stuff. So let's say our right is actually here. Now what we need to say is, okay, so we did call server 1 with time 3. So if we called server 1, that means we need to update this to a 1. And now we did call server 1. So we updated the 0 to a 1, which means this call needs to subtract 1. So now we have 2 uncalled servers left. Okay, now we can move the right over here. And this is, well, let me think about it. Yeah. So our right condition is going to be as long as our right is less than or equal to this value. So that's fine. So we're going to move our right over here, and now we are going to ask, okay, is that less than or equal to 10? Yes, it is. This is server 1 again, so we don't have to do anything. It's the same server. So now we update our right again. And so the right is over here now. And so what we need to do is we need to say, is that less than or equal to 10? Yes, it is. So we can actually move our right again, and then our right is out of bounds, but that doesn't matter. So our right is the entire array now. And if you think about it, it's going to be guaranteed to, because our queries are sorted, if this whole thing is valid for this query, then it's going to be valid for this query, because here we're saying right is less than or equal to 10. Well, it's obviously going to be less than or equal to numbers bigger than 10 because they're sorted. That's why we sorted it. Okay, so now, oh, by the way, so when we're at this 6, we say, okay, we called server 2 here, so this needs to be updated to a 1, and now we only have 1 uncalled server. Okay, so now our right is like out of bounds, so we can forget about it. Because like I said, we're not actually gonna need to calculate the length of the sliding window. We're just gonna need to go through the nodes to get the right bound and the left bound, and then all we care about is this C value here. Now our right is out of bounds. We went through all the logs. Now let's go through the left. And remember, what do we have to do for the left? So the left is gonna invalidate every node that is less than this, because we need nodes between 5 and 10. So our left is gonna start at 0, and it's gonna say, okay, for this node right here, is its time less than 5? Yes, it is. The time is 3. Okay, well, if the time is 3, that means that this node is no good. So now we are actually going to take this. Oh, by the way, I forgot one thing. So when we went through this with the right, even though we did call this node before, we have to update this value to be a 2 because we called it twice. That's going to be important, because when we're going to invalidate nodes, we still have to make sure, like, is there still a valid call to that server? Okay, so we're going to go through this left, and we're going to say this value is invalid because it's less than 5. Okay, so let's take whatever is at server 1 and subtract by 1. So now we're going to subtract this to 1. Now remember, we're not going to change the C value until the server goes to a 0, because we just want to know if the server was called at least once. If it was called more times, it doesn't matter. Okay, so now that left is fine. Now we're going to move the left over here. And now for this value, this is actually in range, so we do nothing. And like I said, where the left actually is doesn't matter. We're just processing nodes. So we're processing nodes that the left is on, as long as the left, is out of bounds. Same thing for the right. It doesn't really matter where it's at, because we're not gonna reset it for each query. We're just gonna leave it. So the left is gonna be over here now. So the left is gonna be over here. But we haven't actually processed it. Like, we're just gonna have a loop that we're not gonna enter until we're at the next query. Okay, so for the first query, we actually do have a solution. So for the first query, our C is 1. And so for our result, then we could just say, like, we're going to have a result array. Everything's going to be initialized to 0. And then we just look at, okay, for this first query, where's the actual index in the result array? Where it's this index right here, because we saved that. And so at index 0 in our result array, we need to have a result 1. Okay, so now we need to go to the next query, which is this one right here. And so for this 11.1, this is the actual query, and what's the range for that query? Well, it's actually 11 minus 5, right, to 11, which is just 6 to 11. Okay, so our right, remember our right, I already went through the whole array. Like, our right's over here. Every single number was valid, and like I said, if every single number was valid for 10, every single number is going to be guaranteed valid for 11. And yeah, so our right condition is just numbers that are less than or equal to this query, which means if they're increasing, if they're less than or equal to some query, they're going to be less than or equal to the number bigger than that number, right? So if they're less than or equal to 10, they're going to be guaranteed less than or equal to 11 because they're sorted. So our right, we don't really have to do anything because we are out of bounds on this list. Okay, well, how about for our left? So this query was in range before. Now is it in range? Our left was here. Now is it in range for this new thing? So we need 6 to 11. So our left has to be, at least 6. Is it 6? No, it's not. It's actually only a 5. So then we do have to, we have to move our left, and we have to process this to get rid of it in our sliding window. So then we go to, so remember this 2 was changed to a 1. in the previous thing because we processed it twice. We added it twice with our right, and then we subtracted it once. But now we are subtracting it again because now it's no longer in the range. So we're going to subtract it. And now remember, for this count, when a 1 gets changed to a 0, the count of uncalled nodes goes up, right? So we're going to add 1 here. So this is the count of uncalled servers. And so when the 1 goes to a 0, that means the server is now uncalled. And when the 0 goes to 1, that means the server is called. So now our count is actually 2. Now we moved our left over here. So we get rid of this. And now we say, okay, is this 6 in range? Yes, it is. So if it's in range, don't do anything. Just end right there. And now for that query, our result's going to be 2. And then like, where do we know where to store it? Well, we do have this index, right? So that's going to be an index 1. So we're going to return this right here. And so that's how you're going to do it. You're going to sort the logs, you're going to sort the queries, and then you're just going to have the right is going to take every single node that is less than the query value, less than or equal to, and then the left will eliminate every node that is less than this value here. And so we're guaranteed to only have nodes between these. And then for our query updates, if you think about it, we're going to be guaranteed moving to the right. Like this left value always is going to be bigger, and this right value is always going to be bigger, right? Like we're going to have 5, 10, 6, 11, and then the next values have to be bigger because the value, if there are values after 11, they have to be bigger. So let's say we have a 13. If the value here is bigger, then the value here also has to be bigger because it's just, you're subtracting the same x value. So you're subtracting 5 at always, so this will be like 8. And so we're like, if you think about it, if you write these ranges are guaranteed just moving to the right. So all we have to do is just update our left and right to make the ranges work. And then that's pretty much all we have to do. But like I said, it's definitely tricky to know to do this. And if you actually look at you can get some hints from like how complicated your solution has to be. So the log's length is 10 to the 5th, which means like an n squared solution here. And the query's length is 10 to the 5th. So an n squared solution would be like 10 to the 10th, which wouldn't pass. So the worst case solution you can have here is n log n or n or better. And so this is going to be actually n log n because we're going to be sorting the logs and the queries. Okay, so now let's code it up. So remember, first of all, what we have to do is we have to make a dictionary for the servers, and we're going to have to initialize every single value in the dictionary to be a 0 for 1 through n. So that's going to look like this. So we're going to make a server, and then we can actually do a list comprehension for dictionaries. So we can take an I0 for I in range 1, n plus 1, because there are n nodes. And so for, if there's like 3 nodes, we want the nodes for every single value to be 0 as a default. Number of times it was called. Okay, now we're going to want to sort the logs. And the way we're going to want to sort the logs is we're going to want to sort them. Remember, the left number is the server and the right number is the time. We're going to want to sort them by the time. And the way to do that is you can actually make a lambda function in Python. And so what you can say is you can do this, and I'll explain it. So, okay, so pretty much what this is doing is it's saying take elements in this and sort them by the second element. So like this would be x here, and you want to sort them by the second element. So you say take x and sort them by x1, which would be the second element. So if I did x0, it would be the first element. So if you did, by the way, want to sort by the first element, that's just like how the default sort works. But if you want to sort by the second or third element or whatever, then you put in the index here. And then you can also do, if you want to do it in like reverse order, you can say like reverse equals true and things like that. But in this case, we want it in ascending order. Okay, now we want to sort the queries. And so for the queries, we actually have to make new arrays for the queries. So we're actually going to use sorted instead of sort. We could use sort as well, but pretty much we're going to make a list comprehension here as well, where for every single query, we're going to now make a subarray of query and I for I query. And I'll explain this real quick too. Okay, so pretty much for every single query, what we want, we're going to want to enumerate the queries, and for the enumerate, it'll give you the index in the query and the actual value. And so what we want is we actually want an array of 2 elements where we actually want the query and then the index that it was in before. And then, so we're going to have this, and it's going to look something like, for this 10, 11, it's going to look like something like this. So it's going to be like 10, 0, 11, 1, because this is enumerated. And then we are going to be sorting by the first element, which is the query. So like these indices might not be in order after you sort. And you can use sorted, or you can actually you can even make it like this. You can't sort in the same line, but you can just do queries.sort if you wanted to, like this. Either one's fine. I just had sorted because it's so you can do a one-liner. Okay. So now we want to get the length of the log, so let's do that because we're going to use that to make sure our stuff isn't out of bounds, and we're going to want to get the length of the queries. Okay. So now we are going to have the output array, and so remember for the output array, we're going to just default it with zeros, and it's going to be the length of the queries. Because for every query, there needs to be a result. So we're going to default it with the length of the queries. And then for every time we process a query, we can just take this I in the query, and then we know where in the result to put our output. Okay, so we're going to have that variable that was C in the picture. We're going to call that no requests, meaning like this is the number of servers with no requests. And we're going to initialize that to n because initially no server got a request. Okay, so now we're actually going to loop through every single query. So it's going to be for query I and queries. So we're going to loop through the queries, and like I said, we can actually do the left and the right separately. The left is going to be guaranteed to like never pass the right because the number on the right is always going to be bigger than the number on the left, right? Like we're going to have like 11.5, 11.6, and so on. So we're going to actually handle the left and the right separately. We don't have to do the way I normally do sliding window. We can actually just do the left and the right separately. So what's that going to look like? Well, we can actually, how far can the right go? Like what's the out of bounds? It's going to be the end of the logs. And then what's the other thing we need to do? So we need to actually make sure that the right is like, do we need to move it or not? So if this is the case, then we can process this node, right? So remember for the right, the node that we're processing, its time has to be less than or equal to the query. So that means now we can process whatever we have, whatever index we're at. And so it's going to be pretty straightforward. So we actually need the server. So that's going to be like this. So remember in the logs, the values are the server and then the time. So logs right 0 will be the server, and then the logs right 0 will be the server, logs right 1 will be the time. So we're saying if this is a valid node, let's actually update its value. And so, but before we do that, we need to remember in this picture. So if its value was 0 and we're updating it, we need to check if it's 0. And if it's 0 and we're updating it, then we need to actually subtract from no request because now that server does have a request. So if server equals 0, we're going to update no request, saying the server actually has a request now. Request minus equals 1. And now we just simply, this is annoying. Hopefully they're not all screwed up like this. Okay. So we're going to update it. And now what we also need to do is we updated no request. Now we actually have to update the value, right? So it was a 0 and now it's going to be a 1, but it might not have been a 0, right? It might have been a 1. We updated to a 2, but the only time we actually update the number of no request servers is when it goes from 0 to a 1 or from 1 to a 0, like I showed you before. Then we just move our node. Now we do the same thing for the left. It's going to be really similar code. So while left is less than L and logs of left 1. And what's our left condition? So remember our left condition for the node to be invalid. So we're getting rid of every node that's invalid. And so for every node that's invalid, its value has to be less than query minus x. So if it's between query minus x and query, then the value is fine. But if it's less than that, then we have to actually get rid of those nodes. And so like I said, this code is going to be pretty similar. So left 0 now, we get the left server. And then now what we need to do is we need to actually check if server equals 1, because it's a 1, now we need to make it a 0. So then we could do no request here, plus equals 1. So if it's a 1 and it becomes a 0, that means that server no longer has any requests. So we need to update no requests. Now we can subtract here for s equals 1. Yeah, that's right. Okay, now we need to move the left. Then we need to update the result. And so in the result, remember, this is why we have the I. So this is the query, and this is the index where we need to store the result. And so that's where we're storing that. We need to update the result, and we need to finally return result. And hopefully I didn't screw up any code. Let's see, unexpected indent. I think it's because these are screwed up. Okay, so now that we updated that, let's see what happens. Hopefully that was it. Oh, right. So we also need to make a left and a right variable that I forgot to do. And we're going to initialize this to 0, as always in a sliding window, or usually. So there we go. No, probably misspelled. Okay. Okay. And so actually, let me look at that one more time. I think it's actually pretty efficient too, but like I said, there's not too many solutions because this thing just came out today. Yeah, okay, so it's pretty efficient. Okay, so let's think of the time and space here. So let's say L, let's just write this down. L is the length of logs, and Q is the length of queries. So here we sorted logs and queries. So that's like L log L already. Right, so L times log L plus Q times log Q. They are both 10 to the 5th, but yeah. So we sorted them, and then this part should be, so we are going through the queries, but our left and our right can, like this thing should just be big O of Q, this whole thing, because we're going through the queries, and then we're just updating the left and the right, but they're only going to go through one time. So that's going to be a big O of Q. So it's definitely going to be that this thing is the thing that's going to hurt it, the sorting. So for space, what are we doing? Well, we did make this like new list for queries with the indices. That's going to be a big O of Q. And then did we actually make anything else? I think that's pretty much it. The left and the right, and then there's no requests or just variables. We did also make this servers thing, which is length n. Yeah, so we did make that as well. So it's actually Q plus length n, which is the number of integers. Yeah, so that's going to be that. And then also, yeah, for the time, like this servers should be way faster than this, assuming they're all about the same size. So yeah, so I think that's all for this problem. Hopefully you liked it, and if you did, please like the video and subscribe to the channel, and I will see you in the next one. Thanks for watching.